Let's try a wedge example where we need to split something. And so to split this wood, we would need some sort of axe, and that's kind of what we got here. In fact, we could even draw ourselves a person. Maybe this is Mr. Anderson here holding some axe, and he's going to drop it downward to split this wood in half. And so we don't think this is a flag. Let's go ahead and label this as an axe here. But solving for the mechanical advantage of a wedge can be a little confusing because it can be a little hard to figure out what numbers are which. And so real quick, let's go ahead and define what our FE, FR, our DE, and our DR will be in any sort of wedge. And let's start with the effort force. We will say that the effort force is just the force exerted on the wedge. And hopefully that makes way too much sense. Whereas the force resistance is the force needed to either split, tighten, or raise an object. So let's say force needed to either split, tighten, or raise the object in question. Now, as for the distance effort, the simple way to look at it is the distance effort is just the distance of our effort force. Let's go ahead and just copy this so we can get the color down. The distance of our effort force. But another way to look at it is it's the distance of the slope itself. And the dr is, of course, the distance of the fr. And so let's go ahead and just copy this so we can get the color again. But another way to look at it is it's the distance we are lifting, tightening, or splitting the object in question. So with that, we should be able to label our numbers as our FE, FR, DE, and DR. So we're given 4 numbers. Well, really, we're given 5 numbers, but we're only going to use 4 of them, as you'll see. But this 250 pounds is clearly the force exerted on our axe or our wedge, and so that would be our effort force. Whereas the 700 pounds it would take to split this wood, the 700 pounds of force would be our force resistance. Now, a little bit trickier is the labeling of your DE and your DR, but if you look, the distance effort traveled by our wedge would be the length of the wedge itself as it is splitting, and so we can say that this 10 inches is our distance effort, and another way again to look at it is the length of the slope of our wedge. And of course, that makes this 3 inches our distance resistance because it is how far the wood will split when the wedge is inserted in. And if you're confused by this 700 pounds both directions, don't be. It's 700 pounds either direction. So we're actually only going to use one of the 700 pounds. It doesn't double into 1,400 pounds. And at the end, we could prove that if we wanted to. But if we're given 4 numbers, if we're given all 4, we can assume there is no ideal effort force, and we are looking for the percent efficiency. And of course, the formula for percent efficiency is just the AMA divided by the IMA times 100. And so we can go ahead and plug those in, and I want to color code that. Let's say AMA divided by our IMA multiplied by 100. And so to find a percent efficiency, we need to find our AMA and our IMA. And of course, our AMA is equal to our AMA-free equation. So AMA equals FR divided by FE. And we know FR is 700 pounds. And then, of course, our FE is 250 pounds. And so we can see that pounds cancels out. And to figure this out, we'll go ahead and plug this into our handy-dandy calculator. We'll say 700 divided by 250. And we get an actual mechanical advantage of 2.8. And of course, our IMA is our IMA-DR equation, so we can say IMA is equal to our DE divided by our DR. And we know both of those numbers as well. We know our DE is 10 inches, whereas our DR is 3 inches. And of course, inches cancels out, and to figure this out, we'll plug this into our handy-dandy calculator. We'll say 10 divided by 3 is 3.3 repeating. And so we can just say we have an IMA of 3.33 repeating. But with that, we now know our numbers that we need to solve for our percent efficiency. It was just the AMA and the IMA. And so we can just plug in those numbers and multiply it by 100. And of course, for our AMA, we got 2.8. And then we'll just write 3.33 repeating for our IMA. And to figure this out, we'll pull out our handy dandy calculator. And so I'm going to go ahead and type this in exactly as written. I'm going to go ahead and hit this parentheses button, and I'm going to hit this numerator over denominator button to get this sort of fraction we got going here. And I'm going to type 2.8 on top. And on bottom, I want to put this exact answer exactly as is. And so to do that, I'm going to hit the second button on my calculator and go down to this in green above my negative symbol is the answer button. So this says 2.8 divided by our previous answer, which is 3 1/3. And then I'm going to close my parentheses and I'm going to type multiplied by 100. And what do we get? We get a percent efficiency of exactly 84%.